take the data across different parts of your cluster. So you might, and then what you find is that if you're doing any kind of distributed compute, you will usually find not like a perfect linear speed up, but usually like a sublinear. It depends on whether you're using Horovod, Spark, or whatever distributed training framework you want to use. So model deployment, inference. So what do you have? An application, REST APIs, wide variety of different kinds of plugins, etc. These are all the things that you use every day, right? So this is what your company wants to hook machine learning up to. Your mobile phone, your software plugins, your web applications, your dashboards. Or maybe so it depends on how you consume machine learning. There's a lot of different kinds of use cases, but when you're doing inference, it's all the same. You're usually connecting to something via REST API, or maybe you're using gRPC or something like that to connect to the application as well. Most of what I see is you put a model in a Docker container, you stand it up, and expose it as REST API somehow. That's what most people do. And then there's a wide variety of serving frameworks out there today as well. So this is something like this is an overview of what that looks like typically. You might have some form of centralized infrastructure. You might have models you're running. You might have your distributed compute. You have a wide variety of databases, and then you have different chips that you might be running on. It's like we run workloads on IBM, on ARM. We run it on Intel. We're running it on NVIDIA, AMD, etc. Right? So this is kind of an overview of all the infrastructure, right? So the applications you saw right there are all up in the corner, right? And then that connects to the rest of your infrastructure. So different companies have done different parts of this better than others. For example, Netflix, for example, has really sophisticated notebook infrastructure, right? So that allows them to run and track experiments very effectively. Sometimes there are just companies that focus on just the kind of this tracking part. Right. So again, just think about the larger application as you're kind of building your models. So when you're doing deployments, sometimes what people will do, if at least they're doing it right, is you make models kind of like you think of models kind of like a component of your continuous integration work actually. So continuous integration is where you repeatedly basically hit push in your Git, your source code, and you run your build, and you get the output from the model, right? So you should think of model deployment as a new extension of that, where you stand up your infrastructure, you use the models, and you access them kind of like a portfolio. So if you want to think about things a little bit differently, think about which models you're using. Some companies will have 5 models, some will have thousands. How well is that model doing? What is it doing in production? Is it losing accuracy over time? So for example, so why would you want to think about this? Say you're doing fraud detection, and you're retraining new models every day because the fraudsters keep moving, they keep changing their patterns, right? Well, so how would you keep up with them? Via making model deployment a first-class citizen in your workflows. So again, there's different kinds of inference: real time, REST, transaction, transforms. So sometimes people run batch job. You might have just a batch job server. You run your job, and then you get the clean output. This is the part I mentioned about ETL earlier. It's called vectorization. You take your data, you clean it up, and then you basically save it as something like a NumPy array, like some form of a matrix. Sometimes you might have, if you're doing recommenders, you might have something like k-nearest neighbors or whatever your favorite matrix factorization algorithm is, etc. Deployment again, batch inference. So this is where you're running. This is kind of like distributed training, but in this case, all you're doing is you're just saying, I have 1 million new data points. I want to run them as a job, and then store the results in a database. Right. So this is again your typical. This is again a very typical workflow that people do, especially when you're doing some form of business intelligence. This is kind of what it looks like. Again, same thing. You have something that launches your Spark application, and then again you schedule your job. It finishes at a certain time. You consume the results in your application. So asynchronous. So another pattern that people might use is something like Apache.